Okay, so we are looking at a couple of more problems in part 2 of this video for my corporate finance class. And on this particular question, what we're being asked is we're being asked the same thing that we were being asked on the last video. So we just looked at which of these projects we would accept, A or B. And obviously we would accept project A because project B's NPV is definitely less than 0. So we would accept project A. So on this question, we're being asked the same thing. We have the same two projects, but we're being asked if we use the payback method, which of these projects that we would accept. And so I've set up the PowerPoint here with just our years again and our cash flow again, but we also have our discounted cash flow. And the discounted cash flow is just going to look like that. So this 0.1 represents our 10% discount. And then we have our cumulative cash flow. And so that's just going to add, obviously, our cumulative cash flow plus our discounted cash flow to give us the cumulative cash flow. We also have here set up, it's kind of different, called a fraction of a year. And so what that fraction of the year is if our cumulative cash flow entry is less than 0, then don't return a value. So you see cumulative cash flow is less than 0, then don't return a value. And we're looking at C7, dividing C7 by D6. So, which is our cumulative cash flow, and D6, which is our discounted cash flow. So that's what we're looking at here. And then down here, we just have our full years. And you're going to be able to see pretty clearly anyway your full years from here. But just to work it through, I've added the full years on here. And then you have your partial years as well. So your partial years, so the full years is just the finding of your negative years of cash flow. And your partial years is just getting the first positive value from this fraction row. That's all we're asking on this partial year. But honestly, at this point, like I said, you can see your fraction of a year and the break-even point. So logically, you'd have your answer. But for the sake of the spreadsheet, we have that in there. And then this is just going to give you a combination of, just one second, I live in a sober sorority. Here's a roommate. Yes. Tay. Okay. So, what we're going to do is we're just going to go and we're going to use the exact same numbers. So this is going to be project A. And so our cash flow, we're going to enter in here, is our negative 10,000, because that's what our cash flow would be. So we're going to enter that in. And as you can see at this point, it says this is our cumulative cash flow because we haven't entered anything else. So our cash flow but that would give us the wrong answer. So we're going to take the negative off so that we can see that our cumulative cash flows at this point are minus 10,000. And you just simply do that by making your cumulative cash flow here be equal minus D5, whatever's entered in there. So then we go over here to our first year. And in our first year, we have 5,000. In our second year, we have 5,000. And in our third year, we have 5,000. And so as you can see, so we have our totals. But as you can see, if this 0.1 representing our 10% needs to be a 1.1. In order to discount the cash flows properly. So by adding that to be a 1.1, across all of these. And then, of course, the 1, 2, and 3 right here represent the years. We get our cumulative cash flows this first year of minus 10,000. And then we see that here we're still minus, so on and so forth. So as you can see definitely for 2 years, you would have a negative cash flow, and then for a portion of this year, which would be 0.352. So according to your payback period, just adding those two together, the E10 and E11, which would be our partial years and full years, and the payback method, this particular project A would be 2.352 years in order to pay that project back. So looking at project B, I have it set up, and this time I have it set up so that, because the common mistake is to think that on that discounted cash flow, that it is the actually 0.1 for 10%, but it's actually 1.1, because that's what the actual formula is. It's 1 plus the interest rate. And then and this is the time, represents the time. So that's something that's important to remember. That's a common mistake. And so for the second project, I have that already set up in there so that you can see. Hopefully that first one wasn't too confusing. Your cash flow in your first year, just like before, is going to be $55,000. And then, as you can see, that shows all the negatives. And then it's going to be $20,000 a year is what they're thinking that the cash flow is going to be. So entering in that 20,000, entering in that 20,000 here. You can see that it is never paid back. The fraction of the year column here shows you, because it says do not, remember this says do not return a value if it's less than 0. So that's why you have these, which means in this particular case as well, you would never have it being paid back. So as you can see here, you would never, looking and just double checking, you would never have it paid back. So on this one again, you would accept project A, because your project A would obviously pay back in 2.352 years. So that's the difference between the two projects. And those are the questions that I've been asked for the assignment, with the exception of, let's look at one more thing, and that is an assignment we have for question number 5. So I'm just going to go down here and looking at question 5. And we're going to open that up. So on question 5, I was unable to do that out by hand, but I was able to set up an Excel spreadsheet for it. So with this problem, we were concerned with the rate of return when preparing. I discovered this is also sometimes called the return on investment. And in this case, we're looking at an annual rate. So our answer is expressed as a percentage for return rate questions. And so the question is, what is the rate of return required to accumulate $400,000 if you invest $10,000 a year for 20 years? Assume all the payments are made at the end of the year, and the annual rate of return formula is the same as we used for interest on question 3. So it's a present value formula, kind of with a twist. And so we plug the information into the formula, and as you can see, this was how we got that was the rate, and then that was 20 years at $10,000. And so that was our 400,000. And so as you can see, it came out to be 7%. So this one I could not do on paper, It just got really lengthy and confusing, but I was able to do my best on Excel.